formula, we have to find under root 1 plus dy by dx whole square. So that is equal to under root 1 plus 10x square, that is equal to under root sec square x, and under root sec square x become sec x. So here is the formula, length of the arc, that is equal to 0 to pi by 3 integration from 0 to pi by 3 under root 1 plus dy by dx whole square dx. So that is equal to 0 to pi by 3 sec x dx, and the integration of sec x, that is equal to log sec x plus 10x, right? So there is a formula of integration of sec x, that is equal to log sec x plus 10x 0 to pi by 3. So put the value of pi by 3, so that is sec pi by 3 plus 10 pi by 3, and minus log sec pi by 3 plus 10 pi by 3 minus log sec 0 plus 10 0, and sec 0 is 1 and 10 0 0, so log 1 is 0. Okay, so just we have to put the value of pi by 3, that is log of sec pi by 3 plus 10 pi by 3, right, and that is 2 plus root 3. So log, the final answer is log 2 plus root 3. So we have to find, we find length of the arc of the y is equal to log sec x. Next question A, second part. Prove that this double integration from f bar dot n caret ds, that is equal to 3v if f bar is equal to xi plus yj plus zk, where S is any closed surface enclosing volume V. So since S is closed, we use Green's theorem, right? There is one important theorem in vector calculus, that is, which is called Green's theorem, and that we have to use here. Green's theorem says we have f bar is equal to r bar, that is equal to xi plus yj plus zk, and the divergence of f, that is equal to 1 plus 1 plus 1, that is equal to 3. So that's why the double integration over the closed surface S, f dot n ds, that is equal to integration, triple integration 3 dv, that is equal to 3v. Question 2b. If f bar, that is equal to 3xyi minus y square j, evaluate integration f dr, where c is the arc of the parabola, y is equal to 2x square from 0 0 to 1 2. And this question was asked in 4 marks. Here is the solution. Integration f dr, that is equal to integration from 0 0 to 1 2 3xyi minus y square j into dxi plus dyj, right? Now y is equal to 2x square, so dy is equal to 4x dx. So instead of y, we have to put 2x square in this equation, and instead of dy, we have to put 4x dx. So definitely our limit of the integration is from x, right? We have to use the limit of x, right, because the whole equation become in term of x and dx. So definitely the limit is also in term of x, the limit of x, that is 0 to 1, because the first coordinate is for x and the second coordinate is for y. So here 0 0 to 1 2, so when we put the limit x, then 0 to 1. Okay, so integration f dr, that is equal to integration 0 to 1. Now y is equal to 2x square, so this term become 6x square dx. Okay, 6x square dx minus dy is equal to 4x dx. So this is 4x dx minus y square, that is 4x raised to 4. So minus 4x raised to 4 into 4x dx, that will become 6x cube minus 16x raised to 5 dx. Okay, so now just simply integration, the integration of x cube, that is x raised to 4 by 4, and integration of x raised to 5, that is x raised to 6 by 6. We have to use that 6 into x raised to 4 by 4 minus 16 x raised to 6 upon 6, integration from 0 to 1, that is equal to just simple numerical illustration, that put the value of 1 instead of x, you will get 6 by 4 minus 16 by 4, 16 by 6, and when we put 0, the whole term becomes 0, so we don't need to put 0 here. 6 by 4 minus 16 by 4 so that is equal to 3 by 2 minus 8 by 3. Take LCM and just simply solve it. That is equal to minus 7 by 6. The final answer is minus 7 by 6. Next question 2c. Show that f is equal to y cube minus z square plus 3yz minus 2xi plus 3xz plus 2xy into j plus 3xy minus 2xz plus 2z into k is both solenoidal and irrotational. Okay, for solenoidal, what we have to prove? Divergence of f, that is equal to 0, and irrotational we have to prove curl of f, that is equal to 0. Okay, so in both we have to prove first of all that f is solenoidal, so we have to prove that divergence of f, that is equal to 0, and here is the equation for divergence of f, that is equal to del by del x into y cube minus z square, okay, plus 3xz plus 2x plus del by del y of 3xz. So this is the coefficient of I, this is the coefficient of j, that is 3xz plus 2xy plus del by del z of 3xy minus 2xz plus 2z, that is equal to, now what is the derivative of x of this term, right? Derivative of x of y cube, derivative of y cube with respect to x is 0, derivative of z square with respect to x is also 0. Now derivative of 3yz, that is also 0, just minus 2x, the derivative of x with respect to x, that is 1, so that's why this is minus 2 is coming from the derivative of this term. Then derivative of y with respect, derivative of 3xz plus 2xy with respect to y. Now derivative of 3xz with respect to y is 0, and derivative of 2xy with respect to y, that is just a derivative of y with respect to y, that is 1. So plus 2x is coming from this term, that is derivative of 3xz plus 2xy with respect to y, and then derivative of this term, that is minus 2x plus 2. So when you add it, minus 2 plus 2 and minus 2x plus 2x, that is equal to 0. So clearly divergence of f, that is equal to 0. So using the definition of solenoidal, f is solenoidal because of divergence of f, that is equal to 0. Now next we have to prove that curl of f, that is also 0, and here is the formula to find the curl of f, that is equal to determinant of I, j, k, del by del x, del by del y, del by del z, and these three terms are exactly the coefficient of I, j and k, that is y square minus z square plus 3yz minus 2x, then 3xz plus 2xy, 3xy minus 2xz plus 2z, so that is equal to I, 3x minus 3x, just del by del x of this term, that is 3z del by del x of into this, so that is 3z plus 2y, okay, I into, sorry, determinant I into del by del y of this term, so del by del y of this term, that is 3x, right, the derivative of 3xy with respect to y, that is 3x, then the derivative of this term becomes 0 and with respect to y, and 2z, the derivative of 2z with respect to y, that is also 0. So 3x minus del by del z of this term, 3x, that is also 3x, okay, so I into 3x minus 3x, then minus j into del by del x of this term, that is 3y minus 2z, okay, because of the derivative of 3xy minus 2xz plus 2z with respect to x, so the derivative of 3xy with respect to x, that is 3y, just the derivative of x, that is 1, then derivative of 2xz with respect to x, that is minus 2z, and minus k into, sorry, minus del by del z of this term, y cube minus z cube plus 3yz minus 2x, so the derivative of y cube with respect to z is 0, the derivative of z square, that is 2z, so minus 2z, minus 2z become plus 2z, and then plus 3y, okay, so that is minus 3y, so this term become also 0, plus k into del by del x of this term 3xz plus 2xy, that is 3z plus 2y, 3z plus 2y, then so this is plus 2y, 3z plus 2y, then del by del y into y cube minus z square plus 3yz minus zx minus 2x, so the del by del y, the derivative of this term with respect to y, that is 3y square, okay, 2y, so this is y square, so 2y, the 0 z square, the derivative of z square with respect to y, that is 0, and the derivative of 3yz with respect to y, that is 3z, okay, so minus 3z minus 2y minus 3z, so this whole term becomes 0 now, so this is plus 2y, so that's why the curl of f, that is also 0, so f is irrotational, okay. So we prove that f is solenoidal and f is irrotational using that divergence of f, that is equal to 0, and curl of f, that is also 0 bar, okay. So next question, question 3a. Solve the following homogeneous system of equations by using Gauss-Jordan method, and here is total number of 4 equations. The first equation is 2x1 plus 2x2 minus x3 plus x5 is equal to 0, minus x1 minus x2 plus 2x3 minus 3x4 plus x5 is equal to 0, x1 plus x2 minus 2x3 minus x5 is equal to 0, and x3 plus x4 plus x5 is equal to 0. Here is the solution. This question was asked in 5 marks, and here is the solution. The matrix equation for the given system of equation Ax is equal to 0, right? So all the coefficient or right hand side all are 0. So, and here is the matrix. First of all, we have to convert this matrix into a reduced row echelon form, because we have to use Gauss-Jordan method. So when we use Gauss-Jordan method, definitely we have to convert the given matrix into a reduced row echelon form, okay. So instead of Gauss-Jordan, if suppose use that word Gauss elimination method, right, just simply Gauss elimination method, then we have to just only need to convert the given matrix into a row echelon form. But here we have to convert the given matrix into a reduced row echelon form. So reduced row echelon form means what? The leading entry, that means the pivots, definitely it should be 1 in that leading entry, in that column. All the except that leading entry, all the elements should be 0. Our leading entry is going from left to right. If there is any 0 row, it should be the bottom of the matrix. So all that 5 conditions are satisfied to become a reduced row echelon form. So first of all, we have to convert the given matrix into a reduced row echelon form using row operations. So here is the matrix. This first row is coming from the first equation, exactly the coefficient of x1, x2, x3, x4 and x5. You can see the first equation, the coefficient of x1, x2, x3, x4, x5. So the first equation is coming from the first equation, that is 2, 2, minus 1, okay. The coefficient of x3 is minus 1, then 0, the coefficient of x4, that is 0, and then 1. The second row is coming from the second equation, that is minus 1, 2, minus 3, 1. So the second row is coming from the second equation, that is minus 1, 2, minus 3, 1. The third row, that is x1 plus x2 minus 2x3 minus x5, that is equal to 0. The third row is from third equation, 1, 1, minus 2, 0, minus 1, 1, 1, minus 2, 0, minus 1. And the fourth equation is coming from the fourth equation, that is x3 plus x4 plus x5 is equal to 0. So the coefficient of x1 and x2 are 0, so that is 0, 0, and another all the coefficients of x3, x4, x5, that is 1, so 1, 1, 1. Okay, so here is our matrix. Now we have to convert this matrix into a reduced row echelon form. So here is the first process, R13. We have to interchange first and third row. because in third row there is a first element is 1, so we want leading entry 1, so that's why we are interchanging first and third row. So here is the third row become first row, that is 1 1 minus 2 0 minus 1. Then second row is as it is, minus 1 2 minus 3 1. Third row is 2 2 minus 1 0 1, and the fourth row is 0 0 1 1 1. Now next process, we are multiplying first row with 1 and add into the second row. So the first row is and multiplying first row with minus 2 and add into the third row. So this second row, in second row you can see minus 1 plus 1, the second row become, the first row is as it is 1 1 minus 2 0 minus 1, the second row become minus 1 plus 1 0, minus 1 plus 1 0, 2 minus 2 0, minus 3 plus 0, that is minus 3, and 1 minus 1, that is 0. Now also we multiply first row with minus 2 and add into the third row. So the third row become 2 minus 2 0, 2 minus 2 0, minus 1 plus minus 2 into minus 2, that is minus 1 plus 4, that is 3. Then 0 minus 2 into 0, so that is 0, and 1 plus minus 1 into minus 2, so that is 1 plus 2, that is 3 also. So the third row becomes 0 0 3 0 3, and the fourth row is as it is 0 0 1 1 1. Okay, so next process, we multiply fourth row with 2 and add into the first row. First of all, we multiply fourth row with 2 and add into the first row. So 2 into 0 plus 1, that is 1, 2 into 0 plus 1, that is 1, 2 into 1 minus 2, that is 0. So here is 0, and then 2 into 1 plus 0, that is 2, and 2 into 1 minus 1, that is 1. So the first row become 1 1 0 2 0 2 1, and also we multiply fourth row with minus 3 and add into the third row. So that's why this third row become 0 0 0, 3 minus 3, that is 0, minus 3 plus 3, that is 0, minus 3 plus 0, that is minus 3, and minus 3 plus 3, that is 0. So the third row becomes 0 0 minus 3 0. Okay, now next you can see this is our leading entry in first column, this is our leading entry, below that we have already all the elements are 0. In second row, this is our leading entry, in second row this is our